now that we've seen the formula for the z-score, it's time to put that z-score into action in a big long example here that's going to take a couple pages and see what z-scores can show us. So suppose the mean height of human males in the galaxy is 70.2 inches with a standard deviation of 2.99 inches. The mean height of human females in the galaxy is 64.8 inches with a standard deviation of 2.79 inches. Yes, those actually are real, but I'm just going to talk about it being in the galaxy because I want to work with Star Wars characters. All right, suppose Han Solo, who is a male, is 6 feet 1 inches, and Rey, a female, is 5 feet 8 inches tall. Who is absolutely taller? Okay, so what's this talking about here? Okay, so we've got a absolutely taller means in a direct comparison. If you stood them next to each other, who would be taller? Okay, fair enough. So he is. He's taller, right? Han Solo is taller by about 5 inches, right? So Han Solo is taller by 5 inches. Done. Now, just a reminder, when you might be looking at this going, wait, 5 inches, what? So just remember there's 12 inches in a foot. And apparently the metric system has not caught on in Star Wars. So if you look at Han, his height is 6 feet, which is each foot is worth 12 inches. So 6 times 12 plus 1 inch extra, which means that he's 73 inches tall. Rey, on the other hand, is 5 feet. So 5 times 12 plus 8. So Rey is 5 times 12 plus 8, which would be 68 inches. That's why it's a difference of 5 inches, because there's 5 inches or 12 inches in a foot. All right, now why is it not fair to directly compare Han's and Rey's height? Well, it's because he's male, right? And males tend to be taller. Han is male, and males tend to be taller. So it's not fair to directly compare them. So as a matter of fact, there are a lot of things like this that we see in daily life that it's not really fair to compare. We can start with just the male-female thing. So males versus females, it wouldn't be fair to compare strength, for example. Oops, if I could spell the word strength correctly, there should be an N in there. Strength. There we go. So women tend to be stronger in our legs, for example. Men tend to be stronger in the upper body, that kind of thing. So shoe size. Right, men tend to have bigger feet. And again, that's partially related to because they're taller, right? The taller you are, generally the bigger feet you have. Pain tolerance. They've done different studies about pain tolerance for men and women. Men tend to be able to handle sharp pains better than women, but women tend to be able to handle long-term chronic pain better than men, probably having to do with childbirth. And then heart symptoms, endurance. The list goes on and on and on. Okay? But there's a lot of other things we run into life that wouldn't be directly fair to compare. So what about ACT scores versus, actually, let me just say test scores. Let's look at tests. There's ACT versus SAT. The SAT is out of 1600, the ACT is out of like 36 or 32 or something. So it's not fair to directly compare those scores. They don't mean the same thing. If you think of your chemistry test versus your math test, they're completely different, right? They work differently. And then you could do medical things like, heart monitors for one group versus heart monitors for another group, things like that. So medical tests for different groups. I'm just going to leave it at that. Like older people versus younger people, fitter people versus, less fit people, etc. It's not fair to directly compare them, right? And then what about just some random ones? So we'll run into this later on. in a project, but peanut M&Ms versus plain M&Ms, their weight, how many there are in a bag. It's not fair to compare them because there's always less peanut M&Ms in a bag. Sorry, that was M&Ms. There we go. Apples and oranges. Get it? They always say it's not fair to compare apples to oranges. Exactly. Exactly. That's the problem. So it's not fair to compare some things directly. So we use z-scores. To compare them, to make relative comparisons. So we can't compare them directly, right? It's like Han and Ray. Han's going to be taller than Ray. Like he's a guy. He's taller, right? But is he taller in relation to all men than she is in relation to all women? That's the question. We're going to make relative comparisons. So let's go back to Han and Ray and look at them. Who's relatively taller? And so that means that we need to look at the z-scores. So compare z-scores rather than a direct comparison, because we just made this big argument that it's not fair to directly compare them. Hold on, I'm going to move my camera slightly so I can see more of the page. There, that was bothering me. All right, so we just said it's not fair. So up here we did a direct comparison. Then we say it's not fair, so let's do a relative comparison. Let's compare the z-scores. Okay, the z-score for Han. Okay, the way z-scores work, it's x minus the mean over the standard deviation. And in this case, we know the population values. They were given to us. But we have to look at the population values for men. All right, so he's 73 inches tall, take away, and it helps if you put this in parentheses, I will say. So 73 take away. Now, what was the mean for men? Men, their mean is right here. That's the mean for men. That's the standard deviation for men. And the symbol for standard deviation, it looks like an O with a tail on it. It's sigma. If you're in Greece, if you have to go out there, to a Greek island, that's the symbol for the lowercase s in Greece, in Greek. So sigma and mu. That looks like a U with a tail on it. It's mu, right? Okay, so we're going to take 70.2 and we're going to divide by 2.99. All right, that's going to get us a value for him. I'll go do that in Desmos in just a second, but I'm going to get her before I go. So for her, I need the x minus the mean for the women over the sigma for the women. So she was 68 inches tall. Take away. Okay, for women, the mean is right here, and the standard deviation's right here. Okay, so 68 take away 64.8, close parentheses, divide by 2.79. All right, so let's go grab Desmos. Oop, that's a screensaver. Pay no attention to that. Okay, so again, put parentheses around it. 73 take away 70.2, close parentheses, divide 2.99. There's Hans. And then Ray's would be, and again, if you hit the division sign first, you can actually make the fraction first. And there we have her value. It's 1.147 if we round to 3 decimal places versus 0.936. Okay, so he's 0.936. She's 1.147. So the one that's relatively taller is her, right? Ray is relatively taller. Not taller if you stood them next to each other. That's not what we're talking about. If you compare her to all women versus him to all men, she's taller. She's on the taller end for women than he is for men. Right? When you look at her group, where she stands in her group, right? She's taller because her z-score is larger. Now suppose Kylo Ren had a z-score of 1.605. What is his height? All right, now this is going to be a little tricky. There's a couple ways to do this. I'm going to show the algebra way, which is if we don't know the height, we're going to call it x. Right? We say we don't know what it is. Now we know the formula for the z-score. The z-score formula is x minus the mean over the standard deviation. And of course for him it would be the men's, right? Because he's Kylo Ren. All right, so I don't know his value, but I know his z-score because the z-score was given to us. It says it right here that it's 1.605. So what I can do is I can put that in here where the z is. And I can say, look, that's 1.605. X is the thing I don't know, right? The height. So I'm going to leave that as x minus. But the mean for men, I do know. It's 70.2. It's up at the top of the page. And the standard deviation, I know as well. It's 2.99. It's also right here for Han Solo, right there. All right, now, this is just a touch of algebra. If we want to solve this for x, we have to get rid of the division part first. So what you do is you multiply both sides by this denominator, right? So you multiply this by 2.99, but it's not fair to multiply just the right side of the equation by 2.99, so you multiply the left side of the equation by 2.99 as well. These cancel, right? 2.99 divided by 2.99 is 1. This is gone. And then there's no more division, see? But then I need to know what 2.99 times 1.605 is. So I'm going to go grab Desmos. Sorry, my computer program was being annoying there. All right, so 1.605 times 2.99. Or if you like, 2.99 close parentheses times 1.605. It's the same number, 4.7985. Multiplication is commutative. You can put either one in front. It doesn't matter. Okay, so let me write that number down real quick. So this is 4. I'm trying to see it. There it is, 4.7985. 4.7985. That's x minus 70.2. And that's all that's left over there, right? Because everything else went away when we divided or when we multiplied by the 2.99. It's gone. So now I need to get rid of the 70.2. I'm trying to get the x by himself. So I can just add 70.2 to both sides. Over here, that's going to go away because negative 72.2 plus 70.2 disappears. And over here, I'm going to have 74.9985. If you don't believe me, let me see if I can get, there it is, Desmos. All right, so 4.7985 plus 70.2, and it is indeed 74.99. We would round that, let's be realistic, to 75. So he's 75 inches tall. Right here. So Kylo Ren is about 75 inches tall. Which is what they were asking for. Now, if you're curious about how many feet that is, you would divide 75 by 12 and then take the difference, right? So it's about 6 feet 3 inches. Right? Because if Han was 6'1", 6'1" became 73, right? 73 inches. So 75 inches must be 6 feet 3 inches tall. It didn't ask, but there you have it. 75 is perfectly fine. But if you're interested, that's 6 feet 3 inches. The other way to do this problem, of course, is just trial and error. Just try different numbers, right? You know that Han Solo at 73 had a z-score of 0.936. So try 74, try 75 until you get as close to 1.605 as you can make it.